Hello, good afternoon, good morning, good evening, wherever you are. Welcome to Greening of Streaming's 2025 webinar. Um, well, thank you for being here. And those of you who were busy for 5 hours yesterday at the MTSS event, you'll know that a lot's happening in this industry, and we are sort of building a community. We have been over the last few years, and yesterday's event showed that that's actually really happening. So don't hesitate to drop any messages in the chat right up front of the call now. If you let us know what you're interested, why you're here, what you expect to get out of today's call, that would be really cool. That will help our speakers adjust to your needs and your requests. And in a few minutes, I'm going to hand over to our first speaker. I'll just remind you of today's exciting agenda. We'll be starting off with a keynote from Barbara Lange, who many of you will know from Greening of Streaming. Actually, I'm the only one in the program that has the word Greening of Streaming as my affiliation, but all your speakers today are affiliated with Greening of Streaming. And when I make my presentation towards the end, I will tell people who does what in Greening of Streaming. But we'll start with Barbara's personal journey. She's dedicated herself to sustainability in media tech for the last 4 years. And so I asked her to start with a blank page and say to us, hey, what have I done over the last 4 years? What have I learned? Where do I think the industry is? And that's the question she'll be addressing. She'll be followed by Mike Mattera from Akamai, who will give us an update on his leading CDN providers' clean energy initiatives. I'm greatly looking forward to that because I don't know them yet. And if the audience doesn't have questions for Mike, I will. He will be followed by Hemini Mehta from the EBU, who will take the broadcaster lens. The EBU is the European Broadcasting Union, with several hundred members, and so she will be talking on their behalf to give us their perspective on sustainability in general, and drilling down towards the end of her presentation on what it actually means for streaming. And we'll have a slightly more techie talk, but Dom will be there, so make sure that, well, actually, no, it'd be difficult to make sure he doesn't go too deep tech. He will be accompanied by another deep tech person in the name of Ian Nock, and they'll have a little fireside chat about our latest publication, which came out just a few weeks ago on power factor, and that's a very unknown and complicated topic, and I hope at the end of that talk you'll understand a bit more about that. Then I'll come back on for a quick community update, let you know what's been going on with Greening of Streaming over the last year. I'm honored to have taken over the running of Greening of Streaming from Dom Robinson, our founder, but as if you've been following, you'll heard Hill has spoken just before then. And the last half hour or so, we plan to just keep an open mic and let everybody turn their cameras on, and we can talk. And so just before I hand over to my first speaker, just to let you know, for Q&A, the Q&A is open now. So don't hesitate in the chat or the Q&A to let us know what you're interested in today. And if you have questions for the speakers, we'll put them into two groups. If it's a question that's something that you don't understand or very specific to what a speaker is talking about, we'll address that in each session. And if it's a more general question that open to debate, we'll keep those questions for the final session. And I'll just check if I'm doing right on time. I'm just right on time, so I'm going to call up Barbara. If Barbara, you could fire up your camera, and I will hand the floor to you.
Would help. Well, thank you, Ben, and the planning team for putting me forward to talk about my journey. I'm really delighted. It was fun to do the presentation because it's a personal story. So I hope you enjoy it, and it's not heavy thinking, but just somebody's story. So here we go. So firstly, My story starts with my parents and my brothers immigrating to the United States from Germany in 1964. I was born in New York. That picture on the left is my baptism day. I used to always joke that I'm the only American in the family and I could be president one day. Um, but after moving from a few times from New York to New Jersey to West Virginia, we settled on a farm in southwestern Pennsylvania where we were fully engaged as gentlemen farmers. For those of you who are familiar in the United States, a program called 4-H, which is all about basically farm husbandry to teach kids. It was a big part of my life, and I was a big sheep person. It was an enjoyable time. And from there, I, became a big knitter. So there's a picture of me with one of my knit projects. I also then went to university. I double majored in chemistry and German, and went on to my work career. I'm also a big fan of cycling. For those of you who, I'm not a crazy cyclist, but I do like to ride. And here, my husband and I, with our family, finished a ride from Washington D.C. to Pittsburgh in 2019, which was great fun. So, it's a little bit about my hobbies. I come from a line of coal mining engineers. My family's livelihood, and of course mine growing up, was fueled by or made possible by the fossil fuel economy. My father was a mining engineer. Both my brothers became mining engineers. So I really understood the value of energy before I even understood the word sustainability. This little town of Marianna there on the left, Pennsylvania. It's a model place. It was one of the first company towns where the workers received a home. And very interestingly, in Marianna, the homes were built in yellow brick, very unusual. Not red brick, but yellow. All the homes are the same, and they're all yellow brick. And the companies paid in company money, and you went to the company store, and you were really owned by the company. The mine suffered some serious accidents, which was not an unusual situation in coal mining to this day even. There was a major explosion that killed 154 people in 1906 that established the mine safety department in the U.S. government. And then there was a fire in 1988 that closed the mine for good. It's a tough and dangerous business, mining, but so crucially important to the development of the economies in the United States and around the world. Today, of course, Pennsylvania is one of the leaders in the modern world around data centers. And in fact, many old nuclear sites, including 3 Mile Island, are being resurrected to serve this new technology that we find ourselves in. And so, here's an example of the old and the new, all in one place. So with that background, I studied my degree in chemistry. So, originally I thought I was going to be a doctor, but that went out the window for a variety of reasons. I was also going to go to grad school and be a biomedical engineer, and put my grad school on hold for a year. And, 40 years later, I've never gone back. But that's okay. I think my life journey was still fine. I started working for Schwarz, a German-owned chemical company. We made surfactants, for those of you who are familiar, soaps, for the consumer product and personal care markets. Fun fact, the same raw materials that go into your hair shampoo, go into your laundry detergent, can also be used in asphalt on the roads. It's slippery soap. It has variety of applications. And we actually used beef tallow as our raw material. So we had 2 facilities, one in Wisconsin, one in Illinois, that basically recycled, if you want to call it that, beef tallow. And that was the raw material for our chemicals that we used for the soaps. And, at that point, I even sort of had a view of circularity and resource reuse, and, I didn't even know that had anything to do with, and it didn't really at the time have anything to do with true sustainability. But, I could look back on it now and sort of imagine that. I then moved on from Sheerex because I became part of the downturn in the late 80s, early 90s. Economic downturn, Sheerex folded, and I went on to move into the academic publishing space. Kind of a big transition, of course, but I was working in chemistry. I was working in chemistry databases. I was calling on pharmaceutical companies, chemical companies, all to present to them various chemistry databases. So I entered a whole new line of work in the academic publishing space, and a whole new industry. I was learning how to sell product, in this case, intellectual product, right? Chemistry database access. And back then, databases, this is dial-up. This is, I remember going to conferences where we would present our things, in a booth, and we'd have to jerry-rig the computer that we rented so that it could accommodate the extensive systems that we were trying to sell. So we'd come with a screwdriver, if they only knew. And then I was recruited. After a few years, I was recruited to join the IEEE. I'd sort of established myself as a publisher person, left my time in chemistry. I really departed from chemistry back then in the mid-90s and really threw myself into the publishing world. Again, navigating new territory. I was part of this revolution of moving content from print to electronic forms, was part of IEEE's development of its digital library, which today is a major revenue contributor that helps the organization do all of its really good work. And along the way, I wasn't thinking any bit about climate change or carbon footprints. I was learning really about systems and how making any one change here could influence something over there. And that's really important when you think about this holistic view of sustainability. So maybe in a way, I was thinking of my future without really knowing it. So along the way, I landed at SMPTE. My journey brought me to the media technology industry. I was with SMPTE as executive director for 12 years and helped lead the organization through some massive digital transformation. Again, I came into this role completely with zero experience. I didn't know anyone. I didn't know anything about the technology. I didn't know any people. I had no Rolodex of special people. I had zero network. And so, and I also was never the top leader. So that was the first time where I took on the helm and was the buck stops with you. And so all things roll down to the executive director. But it was an amazing experience. And I actually look back and think, wow, the board put such a trust in me to lead SMPTE during this time. And so I had to set about learning, and it was never ending. It was, I landed at an organization that was 95 years old, so it was on the cusp of a centennial, was growing. The industry was changing dramatically. This is in 2010 when I started. We, had to sort of develop new revenue streams. We grew our membership. We, of course, celebrated our 100 years, and we did a whole new fundraising exercise in the process. We even merged and then unmerged with our friends at the HPA. So we learned a little bit about, culture and, how you think on the outside, oh yeah, we'll be great partners together. And then, kind of culture clashing got in the way. And, there are loads of books written about that sort of thing. But, it was all good. I had the pleasure of going around the world with SMPTE, doing amazing things, meeting amazing people. One of the highlights was the being able to broadcast from the International Space Station to the SMPTE conference. What a thrilling experience. And of course, I had such an amazing team of colleagues that I I couldn't have done anything without them. They were just spectacular. And full disclosure, two people were not able to attend our final Christmas lunch. This was right at the period of COVID, but Joel Welch and Julie Ellsbury were not able to join us, but they were definitely part of the team too. So, it was a great time. But all good things too must come to an end. And I knew that, I wanted to change again. Like many, the pandemic gave me pause to rethink, and I wanted to sort of take a look and see what I've learned, and also to test myself and see what I can do, in a new purpose and in a new way, and to work for myself, really wanted to try to do that. So with a lot of planning, advanced planning, I did set out to think about what that would be. I was not camping at that moment, but I wanted to share this photo with you because it's the origin story of Kaiba 121. That is a tent that I was in. And that is the foothills of Mount Kilimanjaro. And if any of you are familiar, Mount Kilimanjaro is an active volcano. It hasn't erupted in many, many years, though. But there are, I think, 3 craters that are on the top there. Eventually, we did succeed in summiting. In fact, we stayed one night in the crater, which was an amazing experience. But Kaibo is the name of one of the craters, and 121 is January 21st, the day that we summited. So that's our little origin story for my husband and me. So I took the leap. I left Simpty. I started my own consultancy, Kaiba 121. And to be fair, at first I wasn't sure, where it would take me. I wasn't quite sure, what exactly I was going to do with this idea of sustainability. But I knew that there was a conversation that was missing. And so part of my entrepreneurial curiosity and my evolution, I decided to choose sustainability as my path forward. So I did. I do what you all do, is you create a website. And but to be fair, I really, again, landed in a new space. I didn't know much about sustainability. In fact, one of the first things I did was conducted a number of interviews with people. First, they were friends of mine from the industry, from the media tech industry, explaining to them what I was planning to do and what did they think. And those conversations were really interesting because a lot of people didn't have any real notion of it. So most of them were supportive, of course, but didn't really know how to answer it for me. But in some cases, those connections gave me other connections. And those people were one step closer to the concepts of sustainability. So I conducted a bunch of interviews. I remember one of my interviews was with a gal from Canada. And she talked about the UN SDGs, and I'm like, what? I have no idea what that means. And if you're in sustainability and you don't know anything about the SDGs, then you maybe need to go learn. And I did. So, I'm wearing the UN pin now. That's my reminder. Never forget the UN SDGs, Sustainability Development Goals, for those of you who may not be fully aware. But I really had to learn a lot. I had to understand what does our industry do as it pertains to sustainability. We know that streaming or production, the whole process, not just streaming, but broadcasting, the whole piece of it consumes a tremendous amount of energy. Live production has travel and shipping costs, and manufacturers are dealing with supply chains. And so there certainly are areas of improvement. And, we also have a very unique position in the media sector because we tell stories. We have to move fast and adapt. We're also a global industry. So can't we be leaders in sustainability? So I put up my website. I started doing some blogging. I got invitations to do things. I was really surprised, to be honest. but I got involved with a number of different organizations. I judged the first of which probably was the NAB judging the Excellence in Sustainability Awards. I co-founded with my great friend Lisa Collins the Media Tech Sustainability Series. I then had lunch with Peggy Daw, and she introduced me to the great Dom Robinson. And suddenly I'm part of Greening of Streaming, which has been amazing. And along the way, I've had a few other projects and engagements. These are a few of them. And it's just been an amazing journey since I started. By the way, I started in January 2022. The other thing I did is I joined an association. I'm a fan of associations. I've spent most of my career working in nonprofit associations. I think professional associations add such great value just to learn, network, be aware of the issues. And so I joined the International Society of Sustainability Professionals. And most recently, in April, I passed the test and I'm now certified as a, what they call Sustainability Excellence Associate. And my next step will be to take the next test, which will be then certified for Sustainability Excellence Professional. So generic sustainability, not specific to our industry. So yeah, so it's a lot of learnings, a lot of webinars, many webinars. A couple of things that, you know, I probably don't have to tell anyone here, but it's sort of the time I think is right. We're living in this world of a zettabyte era, you know, where we have so much content being created. Even this Zoom meeting is creating content, it's you know, we don't even have enough data centers or storage, I should say, to store all that data. So that's a problem. And then, you know, this transition to digital and streaming has really transformed not how consumers work, but all the equipment that we buy, the screens, the LEDs that we have, just the process, everything has really transformed, and it's consuming energy. And one of my issues, I think, is that because this is streaming is an abstract, or even broadcast is an abstract, people don't touch that movie, they don't touch that television program. It's all on the internet. I think they have a feeling that it's either somebody else's problem, or because it's in the cloud, I must not be consuming much energy at all. And of course, part of what we're trying to do with organizations like Greening of Streaming is really to understand the true cost, energy cost of these activities, so that we can be better informed, not only for consumers, but also for policymakers. So I'm really excited about the work that Greening of Streaming is doing, and things like today, these sessions that we have will help inform us. And even just this morning, I grabbed this from the New York Times that officially, according to the New York Times, streaming is now the king of TV. So in May, more Americans watch television on streaming services than on cable and network television combined. So it's the first time that's happened over a full month, according to the Times. You know, we knew we were headed in this direction, and now we've arrived. And so the challenge is, of course, on all of us, is to navigate these new times and to really, I think, timing-wise, build in sustainability more and more into our future activities. And so, you know, where do we go from here? And my focus is really to helping the industry turn intent into action. I think, you know, sustainability isn't just somebody's job. It's really a mindset. It belongs in every role within an organization. It needs to become the DNA of the organization and not a sidebar add-on. And when you do that, you will see success for sure. And nobody can do this alone. We need to work together. There's so much new information, new concepts, new data points that sustainability is a domain that we all need to collaborate on and to succeed together. Yes, it can be a market differentiator for those who really need an ROI, but I think it is not something that we can do alone. And so being together in a community like Greening and Streaming and others, it really does help us elevate all together. And the other piece is you've got to start somewhere. You've got to do something. Don't wait for the perfect. Don't let the perfect be the enemy of the good. We have to meet people where they are. Not everyone is ready to overhaul. They can't afford it, perhaps. They don't have all the information. But we should be willing to take that first step, whatever it is, even if it's changing your catering to more sustainable friendly options, reduce your lighting, update your heating, and just your policies is a good way to start, and energize your employees to help make these small changes that eventually lead to integrating sustainability as part of that mindset. So whether it's through groups like Greening and Streaming or the MTSS or other industry efforts, collaborative education, standards alignment, supply chain engagement, I definitely have found my place and find that I want to make sustainability actionable. There's so much amazing technology and innovation and people who are eager to do the same and to collaborate and work together on. And so I want to close with a takeaway. You don't have to start with all the answers. You just have to start with the right questions. I didn't set out to be a sustainability advocate. Like many, perhaps my journey has been a bit of a winding road. But I stepped onto this pathway and realized it's really where I belong, and I feel like I'm want to make the decision. This statement, enough for all, forever, is something that came up during our MTSS conference yesterday. I thought it was so powerful, and I'm going to adopt it from our keynote speaker, Bob Willard, because to me it says it all. Enough for all, forever. So with that, I thank you so much for listening to my story. Thanks for being a part of my journey and helping us to make the media sector greener, smarter, and more sustainable for all. Thank you.
Thank you, Barbara. I feel privileged to have had that little window into who you are and where you come from. I was quite enthralled listening to you, and I have some follow-up questions, but we'll keep them for the discussion. So I now have some ammunition. So do stay right to the end, because I have a question for you, and some questions are starting coming in from the audience, but they weren't specific to what you're saying. So we'll address those moving forward.
Okay.
So I'd just like to quickly call up our next speaker. We're going to change gears, change topic. Mike, are you there? Can you put your camera on?
Hi, everybody. Mike Mattera. Great to be here, and great to be a part of Greening and Streaming. So just to give everybody a high-level overview. So hi, I'm Mike Mattera, Director of Corporate Sustainability and ESG Officer for Akamai. We work heavily with the Greening and Streaming team today on different programming and different efforts there, trying to figure out ways not only where we can have kind of a broader impact on our sustainability focuses, but looking at ways where we can integrate industry best practices into our broader approach. It's been a great organization. We came to it organically, and similar to Barbara's journey, Dom came out of nowhere with this brilliant idea to really start this organization and really get it fed with impact. So at any rate, our vision, mission, and approach to sustainability. So at Akamai, we are creating a safer, more connected world to power and protect life online. And that is translated into how we think about our broader impacts on the environmental side. We are harnessing the power of Akamai Cloud to create a sustainable and equitable future for the world. So as a leader in the internet's ecosystem, we take a responsibility in reducing our environmental impacts. We've decided to produce 5 goals by 2030. And the renewable energy side I'm going to dig into a little bit here. So our 2030 goals today, we have a net zero goal, achieving net zero emissions across the Akamai cloud platform by 2030. So that's all of our deployments and infrastructure today. It covers the predominant amount of countries that we're in, including over the 1,400 networks that we have globally. 100% renewable energy. We are working on powering our global operations, which also includes our offices and our extended AMP footprint and a variety of other areas with 100% renewable energy today. This is a mix of us going out and procuring new renewable energy projects and supporting them, which I'll talk about a little bit later. And also figuring out ways and where we can have a broader impact with our data center partners today. Additionally, we are building efficiencies, building impact, understanding our power consumption more, working on measurement, prioritizing software advancements, and looking at opportunities where we can deploy more efficient hardware. We engage our suppliers. So I know I mentioned earlier in the 100% renewable goal, we engage our data center partners, we engage our hardware providers, we engage our supply chain partners up and down the ecosystem today to delivering business results the right way through our responsible supply chain program. And this could be anything on renewable energy to deployments, to build outs, to manufacturing, to our data center partners, right? Anything end to end there that can have a broader impact. And then finally, our circularity program, we're enhancing lifecycle management, looking at opportunities where we continue and also push recycling 100% of our e-waste to e-Stewart standards today, and engaging our stakeholders in a variety of ways, whether it's on the legislative front, whether it's on the impact front, whether it's on the investment front, looking at opportunities there as well. So I just wanted to kind of give a high-level overview of the renewable energy program today, and just talk about a couple of the key metrics. For those of you that don't know, power usage effectiveness in a data center is incredibly critical today. Understanding what that metric is and how much power that your facilities are actually consuming as a result of the tangible assets like the cooling, UPSs. So today on average, we have a roughly a 1.4 PUE globally. It's across our entire footprint today. That is a steady from what we've seen in previous years, but continues to be an impactful metric at that. Clean energy data center partners. So today we have just over 302,000 megawatt hours of data center partners on our ecosystem more broadly, and they're providing us with clean, attestable EACs today, energy attribute certificates that are more commonly referred to in most markets as renewable energy credits or RECs. And then Akamai caused have renewables. These are coming from the renewable energy projects that we're investing in today. It accounts for just over 161,000 megawatt hours. And these are through things like structured virtual power purchase agreements, but projects that are adding additionality and impact into the market. And today, for the renewable powered facilities that we have in the data center partners, we have just over 140 of them. That accounts for everything to the cooling and the HVAC, to the powering of the infrastructure and the individual servers that we have deployed in those environments today. So our strategy and approach has been pretty unique. We've been working with our data center partners quite extensively over the years, looking for opportunities of how we can get renewable power that is credible today through the attestation process. Akamai, among some of the other organizations, we started working with an organization very early on called the Future of Internet Power. to develop standards on how this pass-through would work, and then how it would broadly get calculated into the broader infrastructure today. And then just to highlight on the renewable energy projects, a lot of the projects that we're working on today, we are taking a consequential approach more broadly. So you might have heard that the likes of those in the Emissions First partnership, some of the big techs, or those working towards 24/7 that you've heard more broadly. Since our infrastructure is so spread out across so many geos, we've decided to take more of a consequential approach, looking at the emissions impact more broadly, and where we're procuring and how we're procuring it. So making sure that carbon intensity matches megawatt for megawatt hour in an impactful way to ensure we're making those reductions effectively. I just want to really take a closer look at some of the things that we're doing, and I had a graph in here earlier, but I took it out because it wasn't showing well, and it kind of has some weird colors in it. So bear with me while I explain it. So we use what is known as location marginal emissions from both Surety and Watt time today to measure our real-time emissions displacement per megawatt hour at each grid node. This essentially helps us look at kind of the broader impacts that we're having, not only more in a real-time sense, but also be able to put this against actual power being consumed across the network at a little bit more of a granular level. In most sustainability programs, you might see yearly or monthly accounting. You could see something a little bit more broadly. Whenever we can gather power at a more local level, we are gathering this to really have more of an impactful view of what's happening in real time, and understanding how that's not only helping kind of the broader renewable energy projects that we have today, but also the broader impacts that we're having overall from total use of power. So we were able to look at this. This helps us not only inference impact, but understand what do we have to do with our partners on the renewable energy side. What do we have to do on the efficiency front? What are some of the things that we have to do kind of more broadly, as a business to figure out ways where we can limit our overall impacts. So what does this enable? It enables accurate carbon accounting, which I just alluded to, gas and coal displaced and overall wind curtailment avoided. So it's showing real and lasting value relative to the overall power being used today, how that power translates into our footprint, and how that impact is translating into our overall use. In strategic setting, in procurement decisions based on the highest abatement potential, so going out in the market, as I mentioned earlier, and looking at renewable energy projects that are having a cause and effect in a little bit of a broader way. And looking at, for those sort of higher abatement projects, a good example of this would be strategic investment that we made in Illinois a few years back, which is to come online in 2026, looking at the total carbon abatement impact as a result of taking old coal out of production and helping to green the grid more per megawatt hour for the level of abatement that you would get. So overall, strategically looking at these choices and making the decisions on the highest potential there for our overall infrastructure. This was the map I was talking about. So these are the projects that we have online in the U.S. today. We have a couple of other irons in the fire outside of the U.S. that have not been formally announced, but and more to come on this. We have some global opportunities as well. So that's the teaser. But these some of the impact we and I'll take the project as an example. Based on the LMEs and based on the marginal emissions and based on the static emissions factors today, for the 48,000 megawatt hours and change that we had for production, there's a 14,800 metric ton difference between the LME and the typical market-based emissions calculation that companies would today. And this calculates, kind of the overall value in what we're getting when we're looking at opportunities in individual markets and understanding what is the highest common denominator that these projects can have, and what is the impact that they're actually having in the grid based on the generation profiles that are happening there at an individual time. So this helps translates into the decisions and impacts and things that we're looking at more broadly. It also helps us figure out how do we get to our net zero goal in a real and impactful way. So that is it for my presentation portion of this. I wanted to leave a couple of minutes for questions because I have to leave a little bit early before the end of this. So Ben, I'll turn it back over to you.
So thanks. That was very quick and to the point. Well, I haven't got any specific. There's been a few generic questions that we're going to address more in the final session. Oops, little accident here. But I have some questions for you. We have a minute or two. For a difficult one first, I'll be the devil's advocate. What do you say? What does Akamai say? What do you, Mike, say to those people who don't believe there's any such thing as clean energy?
So I mean, it's all relative, I guess, Ben, right? I think that clean energy is something that does exist today. It's being supported by corporations. I do think that there's a lot of challenges in how clean energy is being deployed more broadly. So I would say if I were to venture my overall thoughts, I think that businesses can have an impact here in what they're causing in the marketplace today. I would also say that clean energy is key to a transitional approach to our overall impacts, right? As we expand, as we see the growth of AI, as we see the growth of services and things of that nature, as we transform more into this digital age, right. Clean energy is going to become a key component, not only on the reliability side, but a key component in how we more broadly transition into an energy mix that is lower carbon. So if I were to give you kind of my high level today, I think that's why it's important for corporations of all sizes to get involved with talking to suppliers on renewable energy opportunities, working in their own out in the marketplace today on PPAs and creating net new renewable generations in an area where there are higher concentrations of carbon load, and going into those markets and looking for a way for a cause and effect. So to answer your original question, does clean energy really exist? It does. It takes time to produce. It takes time to install. It also takes time to figure out the areas where it's going to have the highest impact. So I would say yes, it does.
Okay, I have some other devil's advocate questions, but first there's an audience question from Francois. Francois from Axido. He's another important person in the sustainability environment, very active, and as is his company Axido. And he asks you, his first great presentation, Mark, how do you handle large suppliers by emissions which haven't started their ESG journey and therefore aren't really able to provide any environmental targets and metrics?
That's a great question. So we work with them directly, and we realize that everyone's going to be in their strategies or their approaches a little bit differently. So direct engagement with those suppliers is incredibly important for us. Working with them, sharing best practices, looking at opportunities on that front, and how those best practices translate into their own operations. And then looking at areas where we can either help support, whether that's through, like I said, information sharing. It could be something like anchoring a PPA as an opportunity, looking at aggregational opportunities and things on that front. But also, helping and showing them, this is where we started, which was just measuring our scope one and two. Now, if you look at our emission statement today, which is posted on our microsite, it's 4 pages long. It's very detailed. There's a lot of calculations that go behind that. So I think end to end, it's really the direct engagement on the education front. It's the communications.
You're not ready at this stage to say we can't work with you because you don't have any data yet. You maybe in a few years' time. I want to push you forward because we have another question, and you've only got a minute or so left. A question from Alithea. If a post facility placed their data in the cloud versus on a local media server, what would be the pros and cons be in terms of emission? I thought to get the answer from you before you leave.
So if you're placing in the cloud versus like a
local media server.
Yeah. So I would say it all depends on the service, right? It's, like on a CDN as an example, I would say it's definitely more, I would say it's more impactful to place it because that CDN and those maps and those operations are overall being shared. So I think you're going to get a higher value for your buck on the carbon emissions side, right? It'll be much lower as a cause and effect on the company because you'll be sharing that. On the other side of that, depending on the services, anything that you have to deploy as a bare metal server is going to have a higher cause and effect, not only on the carbon footprint but the energy usage. It's also going to have a higher impact more broadly because it's only being used for one individual purpose. So anything that can be virtualized and then virtualized into the cloud and then managed, I think certainly can have kind of a broader impact on a reduced energy footprint and reduced carbon emissions footprint.
Well, thank you, Mike. You were a brilliant speaker and perfectly on time. And I gather you won't be able to stay for our Q&A at the end, but Mike is a member of Greening is Streaming, so if the discussion goes on and we need more answers from Mike, we'll be able to handle them all offline. Thank you very much, Mike.
Thank you.
I'll call up my next speaker, who is Hemini from the EBU. And you might want to start with one of the previous questions that you were thinking about answering, or you can go straight into your presentation. The floor is yours, Hemini.
Thank you. So I can answer some of the questions as we go along if you want, but otherwise I'll just go through here and then pick them up at the end. So thank you for having me, first of all. My name's Hemini Mehta. I'm from the EBU, the European Broadcasting Union, which most of you will probably know, but if you don't, it happens to be the Union for Public Service Media across Europe and then a little bit beyond. So I see some of our friends are here from across the pond, like CBC, for example. We also have ABC Australia, some in Asia, etc. So that's who we are. So I wanted to give you a quick overview on the types of the work that we're doing for sustainability across the board over EBU, because we don't really get a chance to give this type of information. So first of all, just to let you know, sustainability is still important, regardless of what's going on in the geopolitics of the world. In fact, with the European CSRD, it's become more and more important. And those that were already on their sustainability journey are still keeping good to their journey and making sure that they get better as time goes along. So that's still something that we're working on, and it's still important to us and our members. So our members, a lot of them still have and continue to be on the path of their net zero strategy. We say that this is a journey and not a destination, because what was good a few years ago is changed to what is good today. So every year it gets more and more stringent, and so we want to keep to that path and making sure that we continue this net zero strategy for those that do have it, or a solid strategy. And a lot of our members have their strategies that are certified and audited by external organizations like the SBTI, for example. On the legal side, we well, there's still TCFD, so most of our UK members, if not all of them, still perform to the TCFD reporting, and others are now going to be starting to move towards the EU reporting of CSRD. In the Nordics, they've always had legal implications, so they've always had to do reporting for a good few years. And a lot of our members, even though they were not mandated to do them, they've been doing them voluntarily to join in to show how important sustainability is. And at the moment, the biggest scope and the hardest scope for us to deal with is scope 3, which is probably the same for most organizations across the world. But also we've got a big focus on looking at scope 3 category 11, which is the units of goods sold, which is why working with organizations like Greening of Streaming is really important to us, because to measure our units of cost sold, so how much is our content, the energy use of our content being taken, and also how do we measure this, is a conundrum that's been keeping us awake for a few years already and will keep us awake for a little while longer, I expect. On the production side, we have a lot going on around production and how to make productions in a greener way. So in Germany and France, they already have national legal requirements that they need to adhere to. So in Germany, there's the German Code of Conduct, and in France, that's just come in. So they need to keep to those requirements and be at least minimal green to the requirements that they have in those countries. In the UK, the likes of BBC and ITV and others are all mandated, or all said that they'll be mandated to have their productions Albert certified. So they've reached a certain minimal level to make sure that they are certified. If you are based in the UK, if you watch any of the programs till the end, you'll see that every single one has the Albert stamp at the end. And there are other EBU members outside of the UK using Albert as well, and they're likely to follow the UK broadcasters to make sure 100% of their programs are certified by Albert. The only carbon calculators that do have certification initially was Albert, and now EcoProd in France and our Francophone members have started to get this certification as well. So just to let you know, that's still an ongoing topic, even though with productions, this has been around, the sustainability aspect's been around for a lot longer than what the tech has started to look at. So it just goes to show that it really is a long journey and a long path. And so at the moment, in productions, we know that obviously travel is the largest scope emissions, but what we do know is that thanks to COVID, in a sense, being able to look after travel and do remote productions, etc., is something that we've already started to rein travel on. So the next largest contingent for us to look at is energy, and looking at the idea of how do we reduce diesel generators from sets and move towards cleaner energy. So we're doing some analysis. We've already done some pre-analysis, which goes to show that across all genres at the moment, about 20% on average of the diesel generator is only used. So 80% of its capacity just sits there and is never used. So that shows that if, for example, if we only had to cover 20% or so, that there are greener alternatives around, like batteries and cleaner generators. So that's something that we're digging into at the moment. On the other side, what's happening internally inside the EBU. So we're trying to obviously work with our members on the CSRD side and trying to get them to understand this, because it's a new regulation that's come in. It's also created for all industries and not just media. So to get our heads around it is difficult. So obviously it makes sense for all of us to learn together, just as we are in Greening of Streaming and collaborating with others. So at the moment, our focus on this is looking at the green narrative, so green storytelling, not only externally to our audiences, which most of you already know about, but also internally inside the organization. So how can we get the sustainability narrative throughout inside the organization, because we tend to do a much better job doing it externally, but not so much on the inside. So that's something we're looking at the moment. We also have a group that looks at classical music, and they've started to do a sustainability group as well to look at how can orchestras move around and travel and still somehow keep green. What are the alternatives? What are the ways that they can do this in order to be as clean as possible? We also have some work that's being done in sports, because live sports is obviously extremely dirty, as most of us know. So we've just recently, in fact, today we've just gone and put some sharing information out on the IBU, the International Biathlon Union, and how the members did the Albert certification for that. So if you're interested in that, that's just come out. So there's like 4 documents around that. As I mentioned, that we're looking at power profiling for work and getting data. So just as important as it is for data in tech, it's just as important for us in production as well, because data is something that we cannot change, and it gives us a good picture of what's going on. So we need data, whether we're looking at it from a production point of view or a technology point of view, which I know many of you already know about because we've been on this journey together. And then the other one is to make our Eurovision Song Contest, which is one of the largest shows on earth, and how can we make that greener? So that's something that we've started to look at since a while, but I guess it formally only went in when it started in Liverpool. So we had a policy that was written, and obviously Liverpool, being done by the BBC, already complied to Albert, but when we had it in Malmo and Basel, we also checked, did some work with the local towns and cities, and also with carbon calculators, etc. But one of the biggest things that we need to do is, one of the questions that's come in already is with the audience, is what can we do to change user behavior? This is exactly the same thing that we need to do with the Eurovision Song Contest, is how do we change the user behavior on the travel side, because that's going to be the largest, and is the largest part of the footprint. I would say it's at least 80%, if not more, depending on where it's taking place. So the other side why we're here is looking at EBU Technology and Innovation Department, so looking at it from a tech point of view. So we're working, as I said, in fact, the more we dig deeper into tech, the more we realize we don't know. And so therefore, to work with others and collaborate with others is really important for us. So we're working on the IBC accelerator on EcoFlow 2, which is looking at the distribution side. We know that some of our studies have already been done with some of our members on this. So I know the BBC has done a lot of work on this, where they measured their distribution supply chain, but also the Germans have done it as well. So SWR/ARD have also already done that. But it's not an easy thing to do, and those organizations are large. So what we'd like to do is collaborate with others to learn about the different parts of the chain and understand how big they are and what can we do to make them more efficient. Again, keeping to the distribution, we have some EBU member groups. So we have the distribution group, which has done some work around this, are looking at it in terms of procurement. As one of our members said, procurement is sustainability's best friend, because what you can put into your tender requirements and or contracts makes a really big difference, and having that as part of the decision making makes a big difference. So the distribution group has started to do some work on that and understanding how can we procure CDNs, etc., in a much greener way. We know that DVBI has also got a group looking at this along with HBBTV. So we're all working on the same things together. So we should be sharing all of this information. We've also got a 5G Emerge project, which is with the European Space Agency, which is looking at the extra capacity as we move towards streaming becoming our larger part of the way our content is distributed compared to satellite. It's one of the big things that we've been looking at, is looking at extra satellite capacity to move between CDNs and IP distribution and the the satellite system in a more efficient way to help with the capacity. So as part of that, we want to look at the energy cost of between IP versus satellite, but also the idea that we should be greener, if not exactly the same as the footprint that's there now. And that's one of the key things that we're working on. We're looking at cloud, which has come up. So we already spoke about procurement, but we've also we worked with Humans Not Robots, another organization here within Greening of Streaming, that to look at a small part of our energy use of the cloud that we had. And we've come up with a report on how best we can use the cloud in a more greener way and get some recommendations. We only did it very small, so the results are not as great as we had expected, but it's a start, and we should be looking at it in a larger view and looking at it from a larger pot that we've got. And we also work with the ITU. So we have the Energy Efficient Rapporteur Group, which was called the Energy Aware Broadcasting Group before, but now I think most people, if not all, understand the idea of the footprint of our tech stack being large and getting larger, but we don't have means to measure it. So that's one of the other groups that we've joined up with. And at the moment, we're looking at energy on the end user devices, and we'll be giving an update where we can. On this, we already know with the end user devices, they're the largest part of the footprint. We found ways, we've had a few tests done, which looks at reducing the pixels to make them slightly darker. And that's done with AI, an AI formula. And then the idea is the machine learning model. And the idea is that we've seen across all genres that there's a 20% reduction. So if you think about it, it's in terms of energy use, it's not a huge amount, but multiply that by the number of television sets that are out there and the number of hours and content being watched, and all of a sudden a small drip in this idea creates a much bigger pond, if not a lake. So we can save a huge amount of energy. So it's still one of the big things that we're still working on. Again, as Barbara mentioned, it's not something we can do all alone. We need to work together on this. So that's the end of my presentation. So I'll stop there.
Thank you. I wasn't expecting all my speakers to be so good with timing. We've still got a few minutes. I have a comment/question. You said 10%, 20%, saving 20% of the TV doesn't seem like much. I believe the industry consensus out there's lots of studies with different numbers, but they're all around at least 50% when you're watching on the TV, that 50% of the environmental footprint comes from the TV itself. So saving 20% on the TV is saving 10% on the overall footprint of the whole workflow. Do you agree?
Yes, if you work it out that way, but then it depends on the studies. So some of them have shown that it could be the end user devices up to 80% of the entire workflow. So it depends which study you take then. But we know that regardless, we know that the biggest part is on the end user devices, particularly.
Just a minute. When you're talking, it's really complicated to talk about that. Because when we're talking about watching on a large sitting room TV, then that's obvious. There's over 100 watts typically in most usage cases. So saving 20% of that is a real impact. But when you're watching on a mobile phone, the carbon impact for the mobile phone doesn't come from energy at all. These are the most energy efficient devices humanity's ever built. They do amazing things for almost no energy. So saving 10% energy, it's the embedded carbon there. And I think having a less bright screen does nothing to the embedded carbon. So I think it will depend on the device too.
Yeah, it was on the televisions that we were working on.
Then there was somebody wants to know from Alithea wants to know from the audience. You mentioned some cloud research. Will you be able to share any of the data from there? Is it already on the EBU website?
It is. I'll put the link into it after.
Okay. So that's an answer to your question, Alethea, who says thank you. Then I think, where are we for time? Is it time for the next one? Yeah, we're still 2 minutes ahead of time. And your presentation was so crystal clear that I didn't have as many questions that came up. But yeah, just one thing that I wanted to ask Mike. And you said people are going towards net zero and stuff like that. Have you, within the EBU, been able to make the case that Barbara makes a lot? She didn't much in today's presentation, but a lot of what she talks about is it has to make business sense. That if you're doing something for the environment, if you can't find the business sense in it, then it's much harder. How's that discussion been among the large-scale broadcasters?
So we've tended to find that if you were talking about 5 years ago, the myth was that if you wanted to be greener, then it's going to cost you more. And now the conversation's changing slightly to the point where if you go greener, it's going to actually cost you less in some cases. I mean, if you look at new technologies, so if we look at HVO generators compared to diesel generators, the HVOs are more expensive. But the idea is that if we end up seeing more and more people using them where needed, or moving to batteries, smaller batteries, and not taking as much energy with you as you claim that you need, then all of a sudden you do end up getting cost savings on there. So it just
you're talking more on the production side. What about
on the production side? Yeah. On the distribution side, again, we know that we've started. I mean, if you look at most of the CDN providers and cloud providers, they will say that they're moving towards renewable energy, and that's great for the broadcasters because whether we like it or not, whoever you use is part of your scope 3 chain. So what we want to do is make sure that this conversation is true, and how much renewable energy are they using, etc. When they say they're moving towards renewable energy. So yeah, there is, and then obviously, depending on where you are in the world, your own energy that you use for your own buildings and studios, etc., will be a certain percentage of green. And we're talking about Europe, it's high, depending on where you are.
Well, thanks, Hemini. I hope you can stay to the end to join the Q&A at the end. And I'd quickly like to invite our next two speakers who are going to have a chat. We have Dom Robinson, our founder, who most of you should know by now, and Ian Nock, a colleague of mine for well over 10 years in multiple places. And they are going to take the floor and get us into this story of what power factor is. Over to you, Dom.
I noticed you relocated very quickly there, Ian, from Costa to the IET.
I have multiple personality disorder when it comes to webinar software and things, and obviously I was in a completely different setup before, which actually is that's actually a Starbucks. I quite liked it that period because it was raining like hell outside.
Perfect. So listen, thanks to Ben for handing the floor to us, and thanks to Hemini and Mike, and a very lively and interesting presentation from Barbara as well, which I really enjoyed. So those of you that know us will know that Ian and I want to go a little technically deep, so we'll just raise that flag up front here, and if you get a bit lost, say so in the chat room or in the Q&A, and we'll slow down and back up a little bit, but we are going to sort of let ourselves off the chains and go for a little bit on a reasonably technical subject. Just to give first a quick couple of words of introduction. So yeah, as Ben mentioned, I founded Greening and Streaming several years ago, and with some delight handed the reins to a much better leader in Ben, and so I still look after our working group 1, which is our language lab, where we look at, in some pedantic detail, we look at terms and measures that we use in sustainability and in the engineering of streaming and broadcast. As those two worlds collide, there's been a tendency to talk across purposes about certain terms and hand wave and glibly comment on the effects of things without really deep understanding, and that's something that I feel strongly is foundational to being able to make good decisions about engineering towards better sustainability. So that's my introduction. Ian, do you want to say a few words of introduction yourself, and then I'll introduce the topic?
Yes, yeah, of course. My name is Ian Nock, of course, and essentially I'm the managing consultant of a small consulting company working in the technology and product area for a variety of different clients, you know, the operators, technology providers, etc. But also I work with the Institution of Engineering Technology, which is the largest UK institution representing the professional engineers working across many fields, one of which includes things like media and broadband and telecommunications. And in that area, I'm the vice chair of the committee that actually manages a variety of different events that we put out to the whole industry as a whole at various places, both through our YouTube channels and also in-person events, particularly at places like IBC, like we have later on this year. And that's what we do. But also as part of that, the Institution of Engineering Technology is also one of the owners of IBC, and through that we take part in the IBC accelerators as a champion, and also sometimes as a pseudo vendor, helping out where we can, because it's important to the IET in terms of its 2030 strategy to ensure a sustainable and better world in which to live, basically. So that's really where we are, and obviously I've been working in a variety of sustainability technology aspects, trying to keep people honest about what the technology really is doing, because I think that's important, that people need to do that. And I think that's done where you and I have a great fun, because you raise a question, I'll give an answer. Where someone else says something's good, I'll point out where it's bad, and where some people say it's bad, I'll point out where it's good, all based on the facts. In fact, just the facts is what I try to achieve.
Yeah, absolutely, and I think we can be sticklers for rigor, and I think that, you know, science is a process of testing things to predict the future until you're not getting them wrong, really, and that's a discipline which sometimes gets forgotten. So let me just set the scene briefly. At Greening and Streaming, we have looked at a number of reports, and I've noticed that there's some questions from Alethea in the chat room, and I'll share some links in a little bit to some of the reports that have historically been shared over the years. Universally, as we read these as a group within streaming, within Greening and Streaming, and then as we discussed them with wider communities such as Ian's, we raised a few eyebrows. There was the early and key association, which still persists as a myth today, is that there is a linear relationship between use and energy, so that if you consume more television, you somehow consume more energy. And while that seems like a logical thing to do, and is often done with great intent because of the desire to create circularity and make consumers involved in the decisions, there are many aspects of the base load of the providing availability of service that do not respond in a linear way. They respond in a quantitative way that tends to be measured in next rollout or next architectural change, rather than in the actual use of those technologies. And as we've dug into that area, we've discovered that it's not just about measuring the energy of something that's going on in the network. It's also a question of where you're measuring that energy, and that was something that Ian started to raise at a number of discussions. And the fine, sharp edge of that conversation is really has really boiled down in a bunch of our language lab discussions to a discussion about something called power factor. So at a high level, what's power factor? What if I told you that a device showing 2 watts of consumption actually requires 20 watts to be generated? So your accuracy about reducing your 2 watts to 1.7 watts as you change the power of your codec, or your TV goes from running showing 80 watts to actually requiring 300 watts of power to be generated. What's going on? And when we make impacts on those last inch measurements, are they actually really having bearing upstream? So we've probably confused you with that opener. Let's go back half a step and actually try to understand what power factor is, and that's really where Ian is the supremo. So Ian, can I hand the floor to you to give us a little bit of a primer?
Yeah, so this is where it gets awkward because power factor loses in the game of trying to create an explanation that works with a 5-year-old, which is who we all are in reality when we're learning new concepts. And it's really hard to explain because it's, in many respects, it's very counterintuitive to the way you think about way things work. But it comes down to just basically how fundamentally we generate electricity and how we distribute it and how we consume it. And I'm just going to share something on screen right now, if you give me a second. So I prepared some slides that will help in the conversation, and not too many, don't worry. So the basic thing we've got at the moment is I'm going to scare you with some diagrams first, mainly because I think we just need to make sure people know what alternating current is. It's weird, but some people don't really grasp fully what it is. And what you got shown on the screen now is alternating current is literally where we supply electrical current that actually varies over time. Normally in the UK, it's 1/50 of a second for the period of one of these variations. So we get 50, and I prefer, actually it's interesting, we have a power supplied at 50 hertz in Europe. 50 hertz obscures really what's happening. The old way of describing it works better. It's 50 cycles per second. So basically the current basically changes to plus and down to minus again 50 times a second to supply the current to everything out there for your lights, for your cooker, whatever. And the way it supplies that current is it also supplies it supplies it in the context of a particular voltage that tries to be stable. I say 250 volts, 240 volts, as you say. And the whole point is that the power generators and distributors then manage that balance between how much current is needed to supply the power in a network. And that's what you see on screen now is the way the current varies. I'm just going to show a little bit of an interesting point here about the power. The power is actually really is the multiplication of the voltage and the current together. And you'll see here I've shown the power is shown in a deeper red with this dotted line here. And you'll see it always stays positive on this particular one because you've got voltage and current varying plus and minus all the way along that line there. And it generates a positive power, which is shown in these two blips here. And everything's really nice with that, really nice. However, reality hits in that the balance between the current and the voltage will go out of phase based upon what you've got connected to the electricity supply. And that's both on an individual device basis and effectively the whole network. And what that means is you end up with this, which is what's shown on screen. It's a really complicated diagram, which is showing that the actual amount of power from the same amount of current and voltage as shown in the other charts, the actual power created is actually lower. Being shown here in the dotted line, shown here just 0.8 there. And here it's gone up to 1, and same on the other parts of this, that it goes up and down in a very negative way. Now, that is the actual technical way of visualizing it, but a much better way of visualizing it is as beer. And what this really is, always better. And you can think of the fact that the real power needed by your device plugged in is shown here. It's the beer part, not the head. It's the beer. The amount of power generated to supply that real power is the apparent power. And the difference between the two is the head of the beer, which is the reactive power. And it's that proportion of the power that's out of phase, or the way that the current and the voltage is out of phase. And so you end up with this thing where you're generating more power at source to be consumed at the same level on the end device. So if you've got, say, a power factor of 0.9, which I'll come to what that means in a minute, that means 0.1 of the overall power is actually in the head, and 0.9 of the power is in the body of the beer. And that only becomes really, really, really noticeable when you realize that power factor in our real life networks tries to be as close to 1 as possible. So we try to have the real power be as close to the apparent power as possible based on our designs of all the devices and components and systems that connected to our power distribution. However, that doesn't always work out. And what it makes a big difference on is if you look here where we've got a very much lower power factor, it has a much bigger head, a much smaller body of the beer. And the effect, therefore, you've got to think about it as the fact that you need to drink a pint of beer, therefore you need to drink a lot more pints of beer, is probably the good takeaway from this. Because you've got a wasted head that's there, that's just in the system, it's lost to you, and if you want to drink a whole pint, then you need to actually, in this case, you have a lot more than one pint of beer to get that in your body. And it really comes down to that, thinking about that concept that that's how power works. And power factor is the ratio of the real power to the apparent power. And why that's important comes about in what Dom has just mentioned about the fact that why do some devices need 20 watts generated when they only consume 2 watts? And it comes down to the fact of why the voltage and current goes out of phase with each other. And that's down to the fact that every device has a different load characteristic on the way current and voltage is actually, the way that current is consumed to transfer into power used, work done, basically, on the device itself. And sometimes it leads, the current leads the voltage, i.e. it's ahead of it, and other times it's behind it. And it all depends on whether the device is and this is where I take you back to your high school physics, maybe, and that is where you have capacitive loads or inductive loads. And a good example of a inductive load is one you know all yourself, in that if you have an electric cooker, that is an inductive load. If you have a washing machine, that's an inductive load. What's a good example of a capacitive load? Well, actually, pretty much all electronic devices which use a switch mode power supply. So they are actually making sure that when you supply constant voltage, which is 240 volts in the UK, that 240 volts, or 230 volts technically, is maintained by the power distributor. They need to achieve the work done for the load, so they need to vary the current supplied. And that's where they control. They control the amount of current generated. And power generators and distributors are constantly balancing the entire system that is the power distribution network to ensure that you've always got 240 volts or 230 volts in your home, and that all the current you ask for is always provided when you want it, whether it's out of phase or in phase with the voltage. It's always there trying to maintain it. Otherwise, you would have your system brownout, as it's lovingly called, which goes from the fact that it would not have enough current there to actually keep it running. So there's a lot of work being done by power generators to do that. And why it's suddenly super critical to that 2 watt and 20 watt thing is because of the nature of modern equipment with these modern switch mode power supplies. We do have an awful lot of power supplies that operate with a sub 0.9 power factor, as low as 0.1. In fact, it varies. It can vary depending upon what it's actually doing at that point. So the standby discussion, all the standby devices that I've actually measured in my home and in my home lab, I should say, they're all basically very low power factors of 0.1, 0.15, 0.2. And in general,
so actually putting the message is sometimes putting something on standby in a 0.01 power factor environment might actually mean that the 0.2 watts of standby is actually using more than the 15 watts or 10 watts that you might be using at full load. So suddenly, when you can't, unless you're understanding what's going on in the grid, you simply would argue, oh, well, I'm using less energy. But that's not strictly true, because you might be creating more demand for energy in order to rectify the power factor.
In fact, that's a very specific one. I know of a set-top box that in general usage uses 3 watts. And you place the box to standby, it uses 0.5 watts. But its power factor of 0.5 watts is 0.1. So actually it's requiring the generation of 5 watts.
Yeah.
Or generating the current to provide that 0.5 watts, but overall it's 5 watts of power being generated, which is more than the active mode. But
so
it's not,
we got, sorry, carry on.
yeah, but of course in all these things, it's more complicated than that, because at the end of the day, it's all about the flow of current. And another analogy, and I did advertise this as being a wonderful selection of imperfect analogies. You got to think about electrical current as like water, and you've got to supply enough water to keep a constant flow and the pressure required at all the endpoints. And if you don't supply enough water, then obviously things stop working. But once you supply enough water, it's got a certain amount of pressure. You can have your shower, you can have your washing machine can work things, and you've got to think of it as a flow. And when you have that flow, if you don't use that water, then it flows back in the system. But there are limitations in the way it can flow back. And because of the way that generation companies and distribution companies manage that flow, sometimes they manage that flow by just spilling it on the ground, effectively, to take an analogy.
Because that's exactly which is exactly what a heatsink does. In essence, on a transformer.
They put a large load and they burn it off in heat, and that's when they've done it bad.
And now,
really,
so that's going to provide a bit of a segue. We've got 2 or 3 themes we want to try and crash through in the next 5 or so minutes. So, so we've given some context as to a key inaccuracy in measurement, which should be reviewed and filtered back into almost all the climate science that relates to the end-to-end streaming ecosystem, because it's simply not even mentioned in any report I've ever read. Until the one which I'll drop into the chat room now for people to find, which is the very discussion that we're sort of promoting here. So if we go to, if I just drop this for everyone into the chat room, there's a link to Greening and Streaming's publications page, and you'll see at the top of there our 5-page paper about power factor and streaming. But one of the key things that we should touch on while we're live on the webinar here is why streaming is uniquely vulnerable. Streaming spans everything. We've got data centers, networks, edge devices, consumer devices. We've got the full sort of gamut, and each stage has different power factor characteristics. Obviously, there's a lot of talk about AI and data centers and data center growth at the moment, so it would be remiss not to think about what's going on in the data center. But I think one of the conclusions that we came to in our research and our paper is data centers are big energy buyers. They make damn certain they don't waste money, and so actually commercially they're quite attuned to being efficient. Their inefficiencies are in being over-optimistic and making too much infrastructure available that's not being used. And so actually, if you look at the PUE of a data center, it's fairly analogous to a power factor measure, and most PUE measures of data centers are topping out near between 0.9 and almost perfect efficiency. They are really quite optimized environments. But as you mentioned a minute ago, there are so many different interconnected systems. And we looked at Romain's results as he'd looked at base loads in routers, and they're sitting at about 85% utilization. So that means that the use from nothing to everything on the router varies their power by 10 to 15%. But at the same time, that their power factor varied from 0.9 to 0.4. I can't remember the exact number, but certainly through a load-based power factor variation. And so, again, this really reinforces the non-linearity of the relationship between use and carbon footprint that ultimately derives from energy. I just want to, I wanted to sort of contextualize that for greening and streaming, that there is a big question about what's going on across these disaggregated large infrastructures and how you can start to account for power factor in that complex environment.
Yeah, and this is where I have some good news. Historically, big, large business users like data centers for cloud infrastructure, they actually, like all business consumers of electricity, they actually get charged for the reactive power, the additional power, that power. So if they have an unbalanced network, which has an overall power factor of less than 0.9, they are generally getting charged at a slightly different rate in monetary terms for that power that is being used by, but the end result of them actually calling off and requiring more power to be generated for the load that they have. So they actually do expend money in power factor correction. And it's an important point to know as well, this conversation about power factor applies to AC current. And of course, that's another thing that a lot of data centers do is they convert to DC power as quickly as possible, and that they actually drive a lot of their infrastructure from DC, because once it's in the data center, that's an easier way of handling it. And you can also focus on making the power supply as efficient as possible, both from a power factor perspective and from a losses perspective. And therefore, they spend money on that power factor correction of that infrastructure, and that's really great. But the reason I draw out the attention about what happens for the actual device itself is where you've got your infrastructure outside of a data center, like in someone's home, consumers don't get charged. It's actually very much a power distributor responsibility to balance that network. And whether we've got inefficient devices that have low power factors or whether we've got efficient devices with high power factors, that's basically effectively a little bit of a Wild West. There is a drive in standards to ensure when you're making large uses of current for larger devices like washing machines, then you should have power factor correction. But in the consumer environment, that's not generally applied.
It's not applied. Yeah.
Not applied. Yeah. And I think the question mark here is how effective is power factor correction, and what do you do about it? Well, better quality power supply with built-in power factor correction would improve things, even if it's only a small amount, simply down to the multiplication factor that we're here talking about millions of homes which have equipment in them which are running inefficiently. And it's important to know that you mentioned PUE and we also mentioned standards. Now, there is some reference to power factor in a lot of these standards, but only from we just need to be aware of it rather than actually managing it. And they're not taken into account in any of the end standards and PU calculations. It is not included in the losses, and that's something to think about.
And what concerns me is that there's pressure for CSRD, there's pressure for other regulatory frameworks to start to assess the energy consumption of digital media groups, digital media platforms and technologies and so on. But we don't have these foundational numbers, right? You know, we have policymakers don't understand the physics, and there's a big regulatory blind spot. Watts per stream is fundamentally meaningless anyway, and it's even more meaningless and possibly out by factors of orders of magnitude without accounting for power factor. So anyone who's relying on anyone's carbon calculator today is using something that's fundamentally wrong. So I think Ian's having a camera moment here.
Yeah, I'm having a camera glitch.
That's okay. There we go. Cool. Oh, that's much better. Let's just last sort of couple of minutes. Let's talk about the scale of the problem and also maybe a few last thoughts about what we can do. Obviously, Hemini mentioned and Ben were talking about the consumer device multiplication issue. Clearly, consumer electronics has little regulation over power factor in these little throwaway power supplies that get dropped out with every device. I liked your comment earlier when we were talking this morning about having USB power supplies in your wall sockets and doing the step-down conversion, so you haven't got hundreds of inefficient power factor-based devices. Maybe you have one high-quality device at the hub of the home, which then delivers DC around the home. Are those the sort of ways that we can really attack the scaled-out problem, or are there other strategies that come to mind?
There can be. There's the world of electrical supply is actually filled with this discussion of what's best, DC or AC. AC won out primarily because it's got an efficient way of distributing the electricity over large distances. Otherwise, all of us would have a power station within 150 meters of where we live, which is not probably a great thing, especially if it's belching out smoke, if it's the old style power stations. In fact, I was recently in Toronto, and there they do have power stations right in the middle of the city, which is quite interesting to see, but that's an historical thing. But that thing of, well, AC supply to the home, and then is there a move towards DC supplies being more commonly done within the home? Thus, they could apply power factor correction at that main conversion from AC to DC. That would certainly offer a lot of interesting possibilities. But of course, we have a massive infrastructure problem with that, because we all have wires in our walls for AC supply. We don't have wires in our walls for DC supply. So at the moment, when I talked about us using USB power sockets, at the moment, every single one of those little power sockets has a little switch mode power supply or transformer contained within them, which is probably horrifically multiplying the issue rather than solving the issue. So, but it is actually, we have to raise that question, considering how many devices we have in the home now that are powered by USB or possibly powered, especially with the very latest 200 watt standards for USB-C. That should really obviously be thought about. But that's a long-term big decision to be had about how do we provide electricity within the home. And I think it would be good to actually make that discussion about, well, is it time that we make that switch back to DC for the consumer itself? And knowing that actually some AC supply is still required, because if you want to use very, very high power supplies, such as for an electric cooker or a EV charging station, then yes, those will still necessarily need that very high power, high current supply, and have a very effective and efficient power factor correction in those. In fact, they do have them in EV chargers. It's a major part of their design, because they're going to have a large impact on the energy consumption of the home. I think there's just been an assumption that we don't have many devices or many things in the home that have these low power factor device characteristics, but actually we do. You know, if you take it from 1970s, when pretty much we had a cooker, we had a television and a radio, to where we are today, where each of us have a tablet, a mobile phone, a laptop, computer at home, a router, mesh routers,
set-top box,
the multiplication of complexity for that. So maybe there really is a need to look at, is it time to switch to DC in the home to solve this efficiency and effectiveness problem?
Yeah, absolutely, brilliant. Okay, so I think we've probably baffled some of the people all of the time, and all of the people some of the time, but hopefully we've got people thinking. I put a link to our paper about power factor into the chat room, so please feel free to grab a copy of that and get in touch with us if you want to get involved in the discussion. I think it's probably too early to be calling for kite marking on power supplies, but I think that's those are the sort of discussions that I would hope to see from the Consumer Tech Association, and indeed from the enterprise tech and the biz tech sort of environment. I think those will help people really understand what energy they are using and start to put evaluated comments about how much that really might translate into an environmental footprint in the long run.
And we have to give plaudits where plaudits is due. A lot of the standards, particularly from the EU, cover all of this, except for power factor.
Exactly.
But they do focus on efficiency. They focus on ensuring that we're always advancing in the face of new developments in the industry. It's just that power factor is the thing where I think there's been a global decision to not worry about it so much on the small devices. But when we've got millions of those small devices, that makes it a big number.
Yeah, absolutely. Cool. Ben, are you out there? Have you got any Q&A for us?
I just had that question of, despite all the technical weeds and complexity, I think some of our people will have understood, a few dropped off, so it got too deep for them. But do we have any grasp, any notion of the scale of the problem? So power is being generated, it's not all being consumed, it's being lost. So two questions. One is, of the loss, Ian said some generators, distributors of power have means to recuperate some of that power factor loss. Others don't. Is it 1% that recuperate, 90%? Do we have any idea of that? And the other question is, do we have any idea of the scale of the problem? How many, are we talking sort of millions of gigawatts, or has anybody done any global scaling of this? How big the issue is?
I think in the power engineering circles, there's probably been a lot of discussion, but in the past, not necessarily in the present. I think there's probably active discussions in the operations of power distribution and generation, but based on the perspective of managing the issue that they have. And from their perspective, all they see is a widely varying load with adjustment in phase of current that they just manage, and if they misdo it, then they dump that load somewhere and we have some wastage. But you see, this is the issue, is I can tell you now, if you try to do the mathematics of how much energy is generated and count all the losses all the way down the line to the end device, the key impact there is you won't end up with a calculation that balances. But if you actually take it back to how they're managing that power consumption, they're just accumulating as one mass, and how effective they are is just written into the reports of how effective they are at balancing current supply to power demand. That's where it fits. But the thing that's an absolute real loss all the time is if I've had to generate 20 watts to supply my 2 watts, I am generating 20 watts, and with losses in the distribution of that electricity from that 20 watts down to my home, I've always got that loss, even if eventually the current is supplied back and piped to somewhere else for use by another set of devices in effect. And that's a real loss. But the scale of that, again, it's who knows yet.
Okay.
Are we actually measuring that? That's hidden behind the boundaries of the power engineering world.
Well, thank you very much, gentlemen. That was enlightening, even for me, although I participated in a lot of the discussions, I still learned some more. And there's more to learn. I'm going to give a very short update. I'll bring it down to about 10 minutes to catch up the lost time. We've had an intro, we've had the keynote, the amazing keynote by Barbara. We've looked at Akamai's clean energy procurement efforts. We've had the operator perspective from, it's not Gemini. That was a spell checker. I know how to write Hemini, but some clever spell checker put Gemini there, so Gemini. Sorry, Hemini. And then we've just had the fireside chat between Dom and Ian. And so in my very brief update, I'm not going to remind you, all of you, what greening of streaming is. There's a website, and you must reach out to us if you want to learn. I just remind you briefly, update you on who our members are, because the last time we gave a webinar, they weren't all there. Some have joined. We've had some turnover, so we've had a few major new join. In the large companies have joined, Arqiva in the UK, and Eutelsat in France, and a few other smaller companies have joined, and you can see we're about 25 members and going strong. So when I said in the opening, it was great to see yesterday's MTSS event because it showed the communities there. Well, we're building a community. I just wanted to put some homage to all the people behind greening of streaming. So it's all of our members, but these are the members, the people who are actually helping run the show. So I'm lucky to be the president at the moment. We have our founder, Dom, you know. Other executive committee members are Simon Jones, who's on holiday, but Mike, you know, Barbara, you know, Veronica Marfino is helping me with all aspects of running the organization and updating the strategy. We have a voluntary secretariat. There's John Behan, Rudolf van der Berg, Tim Siglin, and Andrew Ladbrook, who aren't here today, but who are active members there. And the people running our 7 working groups are Barbara, myself, Andrew, Simon, Dom, and Christoph Neumann from Broadpeak. So I just wanted to pay tribute to that. And quickly to update people on where we are with our energy collecting efforts. We have a project called REM. Before I show you REM, I'll just show you where we started. This is called the DOM diagram because he created this, I think, at the very start of greening of streaming, if not before. So basically, at this end, it should be on your left. You've got sort of, you're creating content, you're doing some kind of encoding or something. And at this end here, you're watching it on a display. And you can go through several dozen devices in the real world. And we said, how are we going to manage to capture the energy flowing from that beast? We have to somehow get our head around it. So we did a diagram that works in the same direction from the origination to the consumption. And we have these 4 basic categories: the encoder part, the blue is the CDN part, the ISP part, and everything that happens in people's homes. which is the home gateway, and all the devices, which can be things like connected TVs, mobile devices and stuff. Everything that's in bright green here, the fluorescent green, is what's operational and has been running for quite a few months. What's in light blue is what we're working on at the moment. We have 2 servers available and we're setting up software on them. We actually have multiple projects here. So we already have 2 live servers in Holland. We should get 2 in the UK eventually. And we're getting to 3 servers actually in Paris in the next few weeks to try and capture this part. And what's exciting about the way we do this is it enables us to do this, which is almost a year old, but not quite a year old, so I can show it. It's new from last year. I've shown this a lot, but it's just one example of what you get because you're doing live end-to-end. A lot of the data out there is all the data about this bit, all the data about that bit. But if you're not measuring it all together, you can't work things out like this to say, well, in an end-to-end stream, again, this is only the 2 termination points, the encoder and the devices at the end. You can see that when you're encoding, you can see this huge jump here on the bottom right. As you move from H.264 to H.265, you're adding like almost 100 watts to the encoding, the power required to encode. And we were expecting most devices, or if not all devices, to behave like this, basically no discernible difference. Sometimes the light blue's on top, sometimes the dark blue's on, but clearly that's just statistical errors. Basically, this device doesn't care whether it's getting H.265 or H.264. But then much more recent high-end devices, we were quite surprised to see a really notable jump in the H.265 to H.264 off a live thing. And this is not the kind of thing you can really do unless you're measuring end-to-end. So we're hoping in the next few weeks, worst case months, to add to this some CDN data as well. And it'll probably be the end of the year or next year we'll also have some ISP data live. Quickly, the very latest stuff, which is still to be fully digested. We're all on a Zoom call now, so this is a whole bunch of measurement from a Zoom hackathon we did. And you can see these orange lines separate, the vertical orange lines, all the different use cases, which are described very succinctly on top. And the way our system works at the moment, we can measure the energy every 20 seconds with a 1 watt accuracy. And so you can see sometimes you can't quite, there's a lot of straight lines, which don't really make sense. We don't quite know what that means. Straight lines that can sometimes go across different use cases. Or so some cases, so what you can see, if you look at the average power consumption, these were laptop PCs and MacBooks. You can see that there is a 10 watt in all these use cases jump with all these use cases. And it so happens that all these use cases had video off and all these use cases had video on. So when you're zooming, guys, you're basically probably consuming, again, we've got to run this again and be more precise, but you're probably consuming about 10 watts on your device by using video. And there's multiple millions of Zoom calls happening every day. So we get this kind of data, but as I say, it's limited. We can't quite make up what's going on because it's not precise enough. So we also have enabled, that's not fully integrated into our platform, it's a semi-manual process. We can do milliwatt measurements at 1 second intervals. And here you can see, whereas I was talking here, 10 watts, jump here. Well, the jump in this is from 24 watts to 25 watts up here. And you can see a screen here that is extremely reactive as long as you get the right scale. And as Hemini, Barbara, several people pointed out, Hemini, I think, when you are talking about screens, you are talking about literally billions of screens. So if you're doing something, if you're in charge of the World Cup and you do something that has this 1 or 2 watt difference on screens, well, you're talking several billion watts. So it can be significant. I said I go really, really fast, so I just want to tell you briefly about one other project that we're quite proud of. It's now with the IETF, so it's in a different time scale. I'm hoping it's going to move forward fast, but it was a simple question that Dom was asking for many years to different organizations, say, hey, we would really like, it's a really simple use case, to understand what's going on in streaming's energy, to be able to find any device that's in my network and say, hey, Mr. Router, hey, Mr. Set-Top Box, how much power are you using right now? Simple question. There's no way of doing that. And we sort of went around in circles, was Dom and people before me were, and so we carried on. And then we realized, well, nobody's actually working on this. So we actually put together our own protocol, which we've called for historical reasons E-Yang. And we're not a standards organization, so we're not going to make that be reality, but we brought it to the IETF, who have taken it on board and put it inside one of their green working groups. So we're quite hopeful that something will come out of that. And one last thing that's very, very new, this from last year, is we're very engineering focused as an organization. And so up till now, we've been, like all good engineers, only publishing things when we've dotted all the I's, crossed all the T's, and we can reproduce the data a second time. We can stand up to scrutiny. But we've realized that the industry, the stakeholders out there, they're asking us, yeah, but what should I do? There was a few questions today. I don't know if that person is still there, but please fire your camera up and we can talk about it. And these are examples of the kind of recommendations we can give to all the different stakeholders. So the way we've cut this up, these 8 columns are the different groups of stakeholders. So the questions today were about end users, but what do we say to content providers? What do we say to ISPs? What do we say to mic and CDN people? What do we say to hardware makers? What do we say to the standards groups? What do we say to the regulators? What do we say to the other organizations like us that we work with? And so we've started filling that in. So this big red thing here is we haven't yet worked on CDNs in terms of recommendations. That's completely blank thing. So that's there. But some of the columns are filling up a little bit. And the color coding here is green, as we've kind of been through 1 or 2 processes and we're quite confident that we've got that right. Orange is, we think that's probably the right idea, but it needs some more work. And when it's got no color code, is we haven't done the process yet for those ideas. And we have got other ideas that aren't on this table. But just to go through one as an example, it's a really simple thing. Ian, you know about this. We worked about this in the Ultra HD forum. Is the power consumption is heavily related to ambient light, and just maybe that something to make streaming greener would be for mass audiences to be aware of that, to all things being equal. If you can close the curtains, it's not spoiling your pleasure or your view, draw some curtains, turn one of the lights off. You will actually bring the wattage down of your TV potentially by tens of watts. And it's better for your eye health too. And then there's a whole load of other things for users. I'll give you an example at the other end of the table. For example, for regulators, we're still working a lot on that. We've got an active working group. I'm really excited with a new member's just joined. Andrew Ladbrook is helping drive this. So this is going to be updated in the next few days and weeks. But for example, there's intellectual property rights that regulators don't necessarily make. It's the property bodies, but they could get involved and say, hey, just a minute, for regulation reasons, we are making people do multiple copies all over the world of certain files just to be safe for a licensing thing, when it makes no technical sense whatsoever. And we are talking about hundreds of petabytes of data being duplicated for regulatory reasons. So we've got, that was just to give you a diagonal thing. This box here I talked about, and this box down the 2 extremes. I could talk for 2 hours over any one of these boxes. But I'm going to leave it there. I hope you've promoted everybody who's still here to panelists so that people can start turning their cameras on, those who want to have a little chat with us. I'm going to stop sharing my screen in a second. Just leave you with this slide is get involved, those who aren't involved, hopefully with us, but we're all about community and sharing, and it's much more important for us to work together in some way, shape or form, whether you join the Greening of Streaming as an organization or not. This is a community and we're in it for the long haul, so we've got to work together. And I will stop sharing my screen, and I wasn't watching the Q&A, so I will now catch up on that. I loved what Barbara, in her talk, as she went away from sustainability, there was stuff on all sides of her life, and she went back to sustainability at the end. And Barbara, question for you, back to the early days, you said you were part of the digitalization of a whole industry. You worked in the digitalization of publication. that was several decades ago. Sorry, I'm not giving you a precise age, but we're both of the same generation, and I was part of the digitalization of other things. And sometimes when I think back, and there have been a few studies, say, on digitalization in the 70s, because it takes about 30, 40 years to do some of the studies. Who did it bring benefit to? And so if you think back at the digitalization of publication, the question is really simple. Do you think it brought any benefit, one, to society? Are we better off with a digitalized publication and stay with publication? And two, to the planet?
I think the answer is yes on both. I will say that the digitization of, in this case, academic content, so peer-reviewed research journals and articles and things of that sort, digitization made it possible for people in every corner of the world, assuming they have internet. So that's a big if, but I think most people, well, I mean, I know there are people that still don't have it, but assuming you have internet, it broadened the access. It made it much more accessible. So I think in that regard, it was beneficial to those readers because they are able to access the technology, helps in their research, and I would say the long-term effect for humanity, for I think you said society. I think the answer is yes, it's beneficial. I think if you did a study on, the carbon footprint of printing content versus digital, I think the long-term effect would be that digital is probably a smaller footprint because printing, it's all the paper, it's all the manufacturing, it's the shipping, it's and some of these research journals, whether it's medical or otherwise, sometimes the paper that they used was pretty heavy. So yeah, I think from a footprint point of view and from an accessibility point of view, I would think that digitization did help.
It obviously democratized.
Democratized, yes.
And actually, it's interesting. You talk about print was democratized back a few years ago. We've got that now in the last 10 years with television and video. I think a lot of the discussion about is YouTube TV is based upon a misunderstanding of the reality of what television is.
Yep.
Television is, if you go back to the raw basics of it, as it was invented, it's vision at a distance. That's it. It's just what you put over it is a different definition. And so it's all TV. It's just whether is it reports? Is it a bit of gaming? Is it just watching somebody doing their gardening? Is it watching them doing a funny dance? Actually, that's content discussion. That's a content. Yeah, plenty of cats. The internet's been full of cats for decades. However, now we've got videos of cats rather than just photographs of cats.
Right.
And I think the challenges for many people about the democratization is we discover an important point of democratization. If people are going to now get more involved, we also reveal the underside of mankind or personkind, about the reality of humans, and that's our area of problem. Is how do we manage those people who are not agreeable to the majority view, and how do we make sure the majority view is a good view?
I mean, I had a little bit of a hidden agenda there too. I mean, I was really interested in your answer for its own sake, but Ian and I have been working for many years with the Ultra HD Forum. I've also done some work with the 8K Association. I'm now working with Greening of Streaming, and so I have this sort of ethical, moral dilemma when it comes to video, is that we know, for example, that HDR on average consumes about 15% more on the devices. We know that devices consume on average about 50%, or they generate about 50% of the carbon. So it wouldn't be crazy to think if HDR was kind of disappeared, I mean, if everything went HDR, we'd rise, streaming would raise its environmental footprint by probably about 7%. But I don't necessarily want to push that narrative, because when I go back to the essence of video, why video exists on the planet and what it's doing is it's there to transmit human emotions. And most of us here are techies of some kind or administrators of it. I don't know if anybody here is an artist that makes video, but I think those are the people who should have the say in whether HDR makes sense if we're to focus on it. And the same when you're talking about digitalization of publishing, of academic publishing, even if the footprint was slightly bigger, if you're doing an amazing thing for humanity and democracy and accessibility, I mean, otherwise we'll just go and live in the trees. If everything that generates carbon is bad,
Right.
you know, let's close this call now and all go home. So the question is, what are we allowed to? And in video, I still have this dilemma. I haven't yet had any clarity to help me have moral clarity on when I'm beginning to get a deep understanding. This is actually really energy intensive. Should I say so, and when should I say so, and call out the red flag, and when should I not? Dom, I think, has done it more from an engineering perspective, and this is more energy there. But when you're talking about creating art in video, are we potentially going to be the harbingers of, not of doom, but of sort of, you know, be some kind of techno-nihilists by saying it uses more energy, therefore we should find another way of doing it?
Well, yeah, here's an interesting thing. To me, it's not just about efficiency, it's about effectiveness. It's sustainability, about doing things, because you can't, for example, if you're cold, the fact that you use a lot of energy, with a heater, is not part of the discussion. Totally. The discussion is that heater as efficient as it possibly can do, considering the job it has to be effective at doing. And I think that's what maybe that's the middle line I take in my sustainability view, is I'm not here to say what not to do and what to do. I'm here to look at the actual technology and go, is this the most efficient way of doing that? Is there ways of making it more efficient? And it goes back to that view I have very strongly, that sustainability is the fourth leg of the standard design triangle of quality.
Triangle, it's the design square then now.
Yeah, it's a design square. In fact, I did refer to it as square in the triangle, or at least maybe the copy editor did that with the headline. But the key thing is that we use energy. The issue is, do we use it effectively and efficiently? And that does also answer the question that if we had completely 100% sustainable sources of energy, would we still be arguing about how much energy we're using? Well, actually, engineers would. They may not associate so much importance to it, but right now we have the opposite issue. At the moment, engineers do not put enough attention to the sustainability aspects of the products and services that we create. And it should be there as a basic requirement.
Dom has his hand up, FYI.
Okay, I'm used to Ben ignoring those.
Oh, sorry. But just before Dom, you'll be the next one to talk, but we've got Josh and Serian. Is that how you pronounce your name?
Herian.
Thanks. Could you just say who I mean, I know Josh, but and I've met you by email, but do you want to just quickly present yourselves, who you are?
Josh,
Sure.
yeah.
Go ahead.
Okay, sorry. So I'm Kerry-Ann Morgan. I work for HSBC. Recently had a chat with Dom. Very briefly met you, Ben, on a call. So just joined. I couldn't make the whole thing, I'm afraid. So I've only been on for like the last kind of 40 minutes or so. But yeah, just I work in Tech Net Zero at HSBC, trying to decarbonize our technology estate, which is vast, as you can imagine. But this is all quite new to me, so I'm kind of more in listening mode. But if I do have an opinion on HD, I would say when I watch an HD television, I think it makes it look very amateurish. I don't know why, but I kind of prefer a bit more of a 2D view, interestingly. But that's all I've got to say on that topic. I'll leave it there.
Well, I'm Josh Gordon. I know most of you already, but I'm on Planning Team 9 at the ATSC organization. And when I join calls like this, I feel like, boy, I live in the dark ages. A, I live in the United States, and B, I work for a broadcaster. So it's, these are very new ideas for the people that I travel with in my day-to-day functions. And I was kind of assigned this, and they said, figure this out. So I've been trying to do that for, I guess, about a year and a half now. And progress is slow, especially at my end of the world.
Okay, well, if it's any help, it was in the US that the first reports of people tracking power factor on consumer devices occurred. Just so you know, you were first.
Also, just so you know, Josh, I'm active in an area called With Life, a whole With Life community, trying to look at the world to kind of see it as the next step after sustainability, and most of it comes from the US. Some of the most active members. There's a lot of stuff happening in California and stuff. So you live in a very schizophrenic country.
There's no question about that.
Tom, you had your hand up for like the last 10 minutes.
Yeah, no, it was when you guys were talking about HDR and the impacts of sort of premium, let's call them premium technologies in the broadcast space. When I think back to do my first webcasts in 1996 and first streams, I needed a transit van full of kit to get on site, to then haul a satellite link because there was no broadband access where I was doing webcasts from. So I was using the most enormous amount of infrastructure to essentially do the same thing that I can now do on my phone as a FaceTime. So one of the things that has interested me on watching the sustainability and energy footprint of streaming with a lot of attention over the last sort of 3-4 years, obviously point one, we don't have any real measurement. I still don't believe a single number I read anywhere. And so net zero, carbon calculators, all of that, it's just laughably, farcically, irresponsibly wrong. And I think that it's gone down a path of needing to justify circularity for the sake of justifying circularity rather than because it has a purpose in actually making consequential change. I've harped on a lot about those issues over the years, but one of the things that also strikes me is without measurement we can't really track what we can sort of instinctively see, which is, yes, infrastructures are getting massively over-provisioned for the latest things especially, but on the other side of it, some of those technologies have got orders of magnitude more efficient because of the demand. So if you create a big demand for HDR, for UHD, then you'll move off software and the consumer sort of cutting edge consumer technologies and start finding DSPs embedded in the TVs, embedded in the portable devices, which maximize battery life and so on. If you don't create a demand and actually have any adoption, then nobody's going to invest in that improved technology. So there's a sort of complicated catch-22. Sometimes you can get to a point where you could deliver 4 times the quality of video and use a fraction of the power that we used to use with MPEG-2 stream 30 years ago, because streaming is now adopted, or SD streaming is now adopted. So there's no reason why HD, HDR, UHD shouldn't become more energy efficient than anything available today if there is enough demand, enough technology investment, and enough innovation in that space. What would be terrible to get stuck in a grey zone where we've got inefficient technologies and nobody invests in them and nobody optimizes them. And what we should be doing as greening and streaming is, rather than trying to say we're a bigger problem than AI, we should be trying to have a bigger impact and use less energy than AI, and work on that innovation and invest in that strategy rather than just try to always promote using less, because it's not going to work. The consumer is not going to stop streaming.
Yeah, you've hit on exactly the point, because that issue about the efficiency, the amount of additional energy required by HDR whilst displaying in HDR images, it's largely driven by the current implementations of the technology for displays that largely are purchased and bought by ordinary consumers, where actually you can't manage the reduced energy usage particularly well because they're not designed for that. LED TVs are like the worst design you could ever think of for creating a display technology, because of the fact they're predicated on the fact that you generate lots of light first and then throw it away to generate the image, which is incredibly inefficient. And you're right, that needs to be dealt with. And interesting enough, a lot of people do lambast the EU regulatory bodies, but exactly that is how they are applying themselves to this. That's why 8K displays and TV display manufacturers had such of an issue. in 2021 about the suddenly not being allowed to import technologies into EU is because they were warned by the EU, there are better technologies for displays out there, you need to implement them, otherwise we will remove certain allowances. And guess what? They didn't do anything, and therefore they had those requirements placed, so suddenly they had to scrabble around to work around the problem. But they still haven't solved the fundamental issue, and that is TV manufacturers at the moment are motivated to use the cheapest technologies for the most commonly bought TVs, because unfortunately consumers have bought into a price point for a display rather than actually the value point. And to characterise that, in 1985 it cost £300 for a TV. Today that's £1,400. And £1,400 today is literally 4 times what you buy a TV for.
I think to join that point and Kerry-Ann's earlier point about, I think you were referring to HD and 4K more, the resolution thing that gives that, especially the early days, the first shoots of 4K made it look a bit amateurish. We weren't used to it. I've lost my train of thought.
No, so, I think Kerry-Ann is also displaying an affection for a cinema look and feel. In other words, lower frame rates, slightly smeary content, rather than being incredibly highly precise and accurate.
I think you feel like you're sort of watching it and you're in it, but not in a kind of good way. And I think it's just not what I'm used to. It feels weird. So, but that is just a purely artistic preference.
If there's any help, it's probably your TV settings that are doing that, because they try to make use of the better displays now with the older content, and they do it really badly. So follow Tom Cruise. Make sure you turn off all that adaptation that takes place, frame adaptation. Motion interpolation is what they refer to it as in very UIs, and you'll find it works a lot better. It's weird.
My train of thought has come back, and I don't know if you talked about it yesterday. I heard bits of MTTS, but fundamental issue, I think, in the whole of our industry, whether media tech, whether it's the people in all parts of the industry, including the telcos for the distribution part, all of us for the last 40 years at least, I've done a little bit of thinking about it, we've had this idea that whatever we can do, the tools we have and the business case we have, we always deliver the best possible experience. Whether that's the best possible image, the most pixels, the brightest colors, the most bandwidth. There are countries in Europe, several countries in Europe, where regular consumers can buy 10 gigabit connections. Nobody has a clue what they're going to be able, and maybe one day we'll have 100 gigabit connections. We've never reached a point where we've said, well, actually, that's good enough. And so part of it's, I think, the business model we've had. That's been driving innovation and the way TV manufacturers work. One day, I was really amazed about 10 years ago. I was lucky to know the marketing manager of Sony Europe or something, and I said to her, how comes you have these on the stickers that when you go into the stores, there's like 15 different things. We do this, we do that, we do this, we do that. The message is so complicated. How a consumer said, well, no, that's the whole, this was off the record, obviously. That's the way we do it. The more parameters there are there, the more confusion, the better. That's how we compete, and we make, that we could jack the prices up. Just, when 3D comes along, we'll do 3D. When 4K comes along, we'll do 4K. When 8K, we don't care whether it makes sense or not. The more, the business is making that. So there's business imperatives. The way our markets work is doing it for the devices. The networks are doing it. And also we're doing it with the images we create. And the thing, you do sometimes have artistic intent. I found when I was trying to promote 4K with French cinema makers, several of them said to me, no, take that realistic look away from me. I want a grainy image for 24. I want it to flicker. I want that's what I'm looking for artistically. But so there are some artists that will fight back, but the tech people, and the whole industry, we're just as good as we can all the time. And I think part of the solution, we've got to find a way, and looking at you, Barbara, who's thinking a lot about how to make our discourse intelligible to business people, how do we bring that, because for today's business, the way they're structured, if we bring that message to market, we'll just get shot down as people you shouldn't listen to. We'll be problem people and not solution people. I don't know quite how to square that.
I had an experiment a year ago. I went to CES, the big consumer electronics show, and I visited all 10 the top 10 TV set makers. And I specifically wanted to see what their messaging was like regarding sustainability and all of that. And it was quite startling to see what was going on. The Chinese and Koreans were very aggressively pushing the sustainability message. Also, the bigger the better. Everyone had a big TV set, and it was like we've reached a point, one product manager told me, where the TV sets have expanded to the point where they can't fit in most rooms. So that's the upward factor. But it's all about trying to get the consumer to buy something that they think is new and hot and is going to look great and all of that. Strangely, some set makers had no sustainability messaging at all. Sony, they said, when I went to the booth, they said, here, look us up online. We've got a whole sustainability website. Barbara.
For some reason, I can't find the hand raiser. I don't know where that went off. But so I've been dipping my toe into the Pro AV space, and it's quite different. It's much more advanced. So I went in terms of sustainability than the media tech. So if you look at ISE in Barcelona versus IBC, let's say, those are sort of, equivalent, and Infocom, which was last week, and NAB. And I've been to all four now. Well, I haven't been to IBC yet, but I will be. I've been to ISE, NAB, Infocom, and soon to be IBC. And two bifurcations. Europe, of course, doing more than in America, but the Pro AV community doing way more than the media tech sector. And I think it's because these companies because Sony is there, Philips is there, Sharp is there, all these display, Row Visual is, virtual production, virtual LED manufacturers, they're all there. But they are being driven by their customers. That's what I asked the question, because I wanted to understand why was Sony saying stuff about sustainability in Pro AV and not in the media market. And the answer is that their customers are asking for their sustainability records, right? And so I don't understand why they don't carry that over into the broadcast space as well. But I think that's maybe a motivation that we can do, right? Those of us who are in the communications side of things, is to help bring, that's why I tried to, yesterday I brought a Pro AV session to the MTSS and to try to bring more of that into the media tech sector. The other thing is the Sony person said in Europe at ISE, we have a whole big thing about sustainability. Infocom, not so much. They just don't do it, right? And so, again, I don't understand. If you're going to do it in Europe, then just do it here too. But I think that's just I think they're being driven by their customers. And I think, we have something to learn from that. So.
Okay, well, that's deviated to the motivations for talking about sustainability. We haven't really addressed my question of quality, and we can close off with this discussion because we're getting to the end. Do we see any path towards being able to, could maybe greening of streaming one day say, this is good enough quality for streaming? So what's quality in streaming? It's all the technical parameters of the video itself, and to try and understand which of those parameters have sustainability impacts. There's the transport of it, there's things like, we've got used to now when you get to Netflix on any device, on almost any network, and you press play, it's instantaneous. Just go back 10 years and everything would be at least a second delay. And everything's got, so one of my intentions with greening and streaming, as soon as we get CDNs up on our REM platform, is to say, is there any way of architecting a CDN that would make it much, much cheaper to run from an energy perspective if it didn't have to always do everything instantaneously? So to try and think about everything's in what you call hot storage. If we put things in warm storage, and what does that have an impact on the energy and stuff like that? So what would be the parameters? We'd have to work out which quality parameters have a sustainability impact, and then say, well, what is good enough? Because, you know, we've gone from SD to HD to 4K to 8K, which is still not quite made it, but you can get 8K content. Are we going to go to 16K to 32K? You know, is there, I mean, there are ways of explaining why 8K isn't the destination. The destination is somewhere in the 16 or 32K. There are arguments for HD. For example, if you take a prism on the quality of the video and say, there's one thing you could say, a lot of the energy consumed in streaming is to take a raw video, compress it, push it down a pipe, and uncompress it. So that compressing and uncompressing is a significant part of the energy. And the efficiency, let me get the right word in, I think it's efficiency, the right word I want here. The efficiency you get for taking a video and compressing it and then uncompress it will be much higher when you have a much bigger video. So the actual, if we just think in the absolute, just don't worry about reality for a minute. How many bits you can get pushed down to so many fewer bits. The more bits you start with, the more efficient that process is. From all perspectives, from energy, from time, from anything, there's a whole load more, the algorithm. So, you know, if I have just 3 bits and I want to find a way of compressing them to 2, that'll cost me a certain amount of energy. If I have 3 terabits, I will do it. It won't be a tera times more. It'll be much more.
The problem is if you've got a 40 terabit network that's lit up all the time.
Yeah. I think
it doesn't make any difference what your compression is.
The problem here is compression's got nothing to do with the energy usage at this point in time, and I think it's actually interesting because we had a little side discussion in the chat with Alethea. You know, it's about understanding what we're actually putting across to people. We're displaying an image, multiple images over time to a consumer, and we've talked a lot about resolution, and actually a lot of content, even movie content, may be captured with a 4K sensor or a 6K sensor or an 8K sensor, but actually it isn't actually, the content resolution is nowhere near that because of the way the creative has done their work. They've actually reduced purposefully the resolution of the content itself, and then when we take that content and put it into a distribution space to distribute it, we then compress it for that decompression and recreation on the screen, and that compression affects the resolution of the imagery. And the display at the end has got its own resolution, and the key thing to know, what you're actually seeing when you watch a TV program is not a 4K image, not a HD image. You're displaying an image at the resolution of a display, which isn't the same thing. And I think that's an interesting discussion point. And as opposed to that compression decision in distribution, TV manufacturers or television service operators have been making that decision in different ways for different countries now since the dawn of time. So in the UK, Sky, they push their Ultra HD services out at 30 to 35 megabits per second. I go to Holland, they do it at 25. I go to Portugal, and they're trying to do it at 12 to 14. And what's the difference between all of those? They're just different levels of compression because you can't change the laws of physics on the content. And the only way you're compressing it with a lossy compression system is by throwing stuff away, and therefore it's a lot lower resolution through the compression in reality terms. And then, of course, they show it up on a 4K display and expect it to look like 4K and wonder why the consumer says, I can't really see the difference. Because actually, by the time it gets there, in many instances, particularly not from the UK, it's not even close to 4K at that point. And people who are in the AV community know about this because they're still the ones buying Blu-rays. because Netflix overcompresses as far as they're concerned. They need that nice, pristine 50 to 100 megabits per second service.
Okay, guys.
But that's a great discussion for another conference.
Yeah.
We've reached the end of our time, guys, and a few people have hadn't turned their cameras off, but they've dropped now. So I'd like to thank you all very much for staying till the end. I learned a lot from all the presentations. It was a great event for me, so thank you all very much.